jadi ke Depok.
Jadi di itu toh ya.
Iya.
Wah, gede banget tulisannya. Gede banget.
Aku dapat aku dapat lu mau saya? Yes. Sumpah. Kasih ya. Air panas. Jangan dong. Sedih dong. Pagi wes. Morning. Go ahead and do the pre-test on fasteners, not springs, fasteners. I don't know which week I put it on. Which week is it? Week 13?
Fasteners. You put at week 12 fasteners.
Yeah. Do that one.
Okay.
Yeah. Oh, I think so.
He's styling nothing with this.
Ini namaku masih di sini. Hapus saja. Biasa
Oh, 16.
salah sendiri masukin nama gua.
Kalau kayak gini tuh berarti bisa kenapa ya? Makin banyak.
Okay, I'm returning the quizzes. Brilliant. Caleb. Madeline. Richard.
Yes.
Mikhail. Oh, do you guys need this back?
Yes.
Madeline. Sorry, it's probably yours. Brilliant. Mikhail. Mikhail Cristiano. Adelric. How do you pronounce your name?
Adelrico.
Adelrico. Emam Aiman. Rayfan. Angelica. Matthew Tandian. Matthew. Nicholas Julius. Vincent. Edward. Wemby. Nicholas Edward. Ryan Amelia. Justin. Amadeus. Mikael Luis. Arif. Nathan.
Ayo lo question mark. I see you with this.
Everyone is here?
Yes. Bang bang. Bang bang.
No, just checking the attendance. Okay, refund again. This belt and chain. You just have to twist. Sorry, this one is not graded yet. So, for the bushing problem, you will not end up finding it if you apply F1 as 1.8 because the bushing available in that table will not be adequate. What you can do is you can stack up two bushings to make up for it. But I didn't make that comment in the problem. I think I deleted it during the problem creation or modification. So it is graded as to check your understanding. So if you show that you have understanding, you still get credits for it. But in order to improve your grade, I'll make a remedial quiz for that topic, okay? For the pushing topic. But the gears, should be straightforward. Go ahead and find the problem, the mistake that you did on that problem.
It's a remedial for the number one, is it?
For number one, pushing.
For everyone.
For everyone.
To improve our score, is it?
Yeah.
And when is that?
We'll find a schedule for it, maybe on that Tuesday.
Okay.
Yeah. Tuesday is usually available for all of you, right? Tuesday afternoon. Yeah. Or do you want to do it right now instead?
No. Cannot. Forgot
I mean, you just figure out your mistake and then you can redo it. Isn't that?
We forgot about it already.
No, I mean, like you can study it now.
No, sir. We need time to get used to it. Sir, can I ask you a question? Can how do you say one? And this 1.6? When we discuss it.
Yes, first try one. Is your, do you get points taken off?
No, like, can I know what you said?
Yes, my grade.
That is one, I understand.
Okay.
Oh, this one, I understand. Yeah.
I don't know. My grade. I don't know. That first. I don't know. I'll have to ask Yeah, there's no problem with that.
This is not.
Like this.
Okay, any questions after you study it? Any questions on the bushing or gear? For the gear, you're supposed to not have it in line, so you can just pick any combinations for M4 and M5 that will make it minimum, right? As long as there is no gear interference. So that's that. For the bushing, if you're stacking up two bushings in series, so let's say this is the shaft, right? And then you put a bushing two next to each other. So let's say the first length is what, 30, and this is the second length is also 30. Then the total length is basically 30 plus 30. That's it, right? So you can have a length of 60 by stacking up two bushings in series to one another. Because simply you think about it as one long bushing. That's a solution if you cannot find the bushing that you need. If you have the first trial for the bushing, some people ask, you first try F1 and F2 equals to 1, and then later on you put in the right one. That is correct. The approach is correct. If you got points taken off, maybe you can see me after the class and just give me back the quizzes. I'll credit that back, okay? Because I have a grader who grades that. So this is correct, and then later on you put in what, 1.8? Yeah? What? And 6, right? For the dusty environment. Yeah.
So, since in the question it says dusty environment, right? So the first
Is it clean or dusty?
Dusty.
Yeah.
So the first assumption still is what? F4, F2, or is it 1?
It's up to you, I guess. I mean, remember, it's an iterative process. If you know it's going to be 6, you can put 6. But you can also put 1. I mean, it doesn't matter. What matters is at the end, you do a check, right? And it has to satisfy the final check. So if you want to make it worse at the beginning, that's fine. But F1, you cannot know, right? That's the problem. I mean, some of you are just more, what do you call it? Ritualistic. You know that? Yeah. So if I teach you this is 1 at the beginning, maybe you do 1, which is not a problem, but you know in the end you're going to have to adjust, right? As long as at the end you do a check with 6, that's not a problem, is what I'm saying. Okay? I can give you the points back for that. Any questions? Yes? Yeah, you put 1, but at the end you do check with 6, right? Yeah, at the end of the class, just hand me back the quizzes. As long as you put 6 at the end.
Yeah.
Yeah. So this is the 11th week, right? 11th. The remaining topics we have are fasteners, which we'll do today, springs, which we'll do next week, 11, 12, 13, 14. So we have 2 extra weeks. I have motor sizing. Maybe, I mean, it's optional. It's an optional topic. And I might do maybe a quiz review to review it again, because on the final exam will be composed of a combination of multiple choice quiz, just like your pre-test and post-test, and a calculation, just like the calculation quizzes, but it's only probably 2, not all of them. So maybe something like a 50 multiple choice questions plus 2 calculation problems.
Oh, like 15 theories, sir.
Yeah, multiple choice.
Oh, if it's theory, okay. If it's calculation.
So this plus 50.
Okay. Any questions on gears and the quiz you just got back?
The question theory or just like numbers?
Just like the post test that you did.
Oh, that's for the final answer.
Yeah, final exam. So next Tuesday, you'll do a calculation quiz again on linear motion, the material from last week, power screws, and today's material, fasteners. Okay? Tuesday.
Next Tuesday or next Tuesday?
Next Tuesday. I mean, you know my quizzes. It's like exactly like the problems I do in class.
Yeah.
I'm really curious. I mean, is there any? I felt that my quizzes are the easiest compared to other.
Sir.
No? It's so predictable, right? But well, the bushing one, I forgot to tell you, it can be 2 bushings. But other than that, it's the same.
Sir, take the questions yourself.
Yeah.
Why?
Maybe you have a source.
Well, I mean, I combine. Basically, it's the same problems as the lecture, right?
No.
Which one is not? Oh, the one not in line?
Yeah.
You mean the numbers are different?
No. Like the belts one? Maybe like only single.
Belts and names different,
Yeah,
sir.
there's
Because in our last quiz, we were not told like one of their diameters, so you can like choose it ourselves.
Yeah.
Oh, the bushing.
The belts, you didn't tell us one of the diameters, but and for the chains, we were told to find our own horsepower. So the horsepower is not like given.
Oh, come on. That's such a simple math, right? Power is torque times.
Yeah, no, but the horsepower watt to horsepower.
What to more
Converting from watts to horsepower.
Did I not?
No.
You don't want to sacrifice power, but it's converting to horsepower.
Yeah, exactly. Yeah. From
I give you the torque in.
yeah, you gave us the formula for the
Oh,
power.
right. The torque is in horsepower.
Yeah.
Extra point.
So what did you guys end up using?
We just like, we just asked the horsepower.
Why did you not ask Miss
She doesn't
Cynthia?
know. She doesn't know.
Well, she can call me. I told her to call me because I'm away in a meeting in Jakarta, so she can call me.
Sir, for when we're adding the two lines, right? Do we use like data from here, then we average it out, or like we find the total?
You pick two bushings. I mean, these are the available bushings. These are the available bushings, right? The table. And so let's say you pick this one and this one. Or you pick two of the same thing, which is easier. You just double it up.
Oh.
Right. The diameter has to be the same because the shaft goes through the same bushing, right? And the diameter you use has to be the inner diameter. Because the shaft goes in the inner diameter. So this is the bushing interface with the shaft, right? I have a feeling I have to give quite a few remedials here.
Yeah. What of us?
Sir,
Quite a few.
why can't we have the remedial for the gearbox as well?
The gear problem, no excuse on that, right?
I don't need the bushing one. I need the gearbox one.
The gearbox one is lower than my.
Well, I mean, I give you the remedial because I give you not enough information to do the problem, right? So that's why.
Oh yes.
Not because you are performing poor, but because there is some part of me contributing to that. So that's why I give you the remedial.
Sir.
Yeah.
So for the bushing question, right? When is the remedial?
Now next Friday is a holiday, is it? No? Is that a good surprise or a bad surprise?
It's a bad surprise.
I was so excited. Good Friday?
Good
No,
Friday.
first of May.
No, the first
The first of May.
Oh, 2 weeks from now.
International Labor Day.
Yeah, maybe we'll use next Friday as the remedial.
Holiday.
No, that's next.
That's next week.
Yeah. Okay, so this coming Tuesday is the quiz for linear motion and fasteners today. And then Friday we'll do a remedial for bushing and chain.
Bushing and chain.
Because chain, you didn't have the conversion number, right?
Oh, by bushing, you meant like plain bearings.
Yeah, plain bearing. When I say bushing, I mean plain bearing. Okay? All right.
Next week.
Okay, let's move on. So let's talk about threaded fasteners today. Bolts, screws. Think about fasteners. I mean, why do we call it fasteners? We call it fasteners because the purpose is fastening, right? So to fasten something is to put the two together, is to assemble. Now, of course, there are permanent fastening type like welding, gluing, riveting, and don't underestimate gluing because industrial adhesives actually is very, very powerful. Some UAVs, unmanned aerial vehicles, they are composite skins over some stringers, but they are glued, they are not riveted because all the rivets will add weight to the airplanes. And with drones, you want it as light as possible for obvious reasons. So they use a lot of industrial adhesives in aerospace, and they are very strong, very strong. So don't underestimate adhesives. Welding is challenging for anything other than steel, right? Even stainless steel, aluminum, you cannot weld them easily. You can weld aluminum, it's just tough. You have to use TIG welder, TIG, tungsten in gas, and it's such a narrow window of temperature that you have to aim for because otherwise you'll just drop and melt to the floor. You just punch a hole to it, rather than melting it and making it fuse. So welding is challenging other than anything other than steel. Stainless steel is also a bit challenging to weld. Rivets are plenty. It's just that it's permanent and it's not always practical. But for airplanes, I mean, you see the rivets in airplanes, right? Every time you enter the airplane, near the door, you see the rivets. Because you want smaller bolts, permanent, it cannot get loose. Obviously, you don't want any fasteners getting loose. Now, what we study here is the temporary fastening, which is bolts or screws. Okay, so in this category, we have threaded and non-threaded. This is the keyways and all that, but that's kind of something else. We are focusing on threaded fastener, and here there are all kind of bolts. Basically, the core technology here is the thread, right? Have you gone to ACME yet?
No.
Not yet. Okay. So you'll learn tapping and die. Okay, but they're just very practical, right? To join things together. They're simple to manufacture. They simplify repairs, safety. Nails are the predecessors of bolts. It basically relies on friction rather than on the helical threads. Simplest and quickest, not the strongest, but it works in wood because, well, first of all, it's softer than metal. But when you go through it, you kind of open the wood material a bit and then it kind of clamps it back down so you have a good grip on wood. So nails work for that. But for metals, and with this course is machine design, therefore it's metal mostly. And we have to have the cut threads, okay? And these are machined using die, lathe, and the holes are tapped. These are a bit different, okay? So these actually bite into the material directly. This one has a counterpart, right? The counterpart is a female thread, whether that's a nut or that's a thread tapped into the opposite material itself. So whenever you see a, let me show bolted assembly. So when you bolt the two together, okay, I don't know whether you can see this, but these are the two plates. Oh, here's a better one. Okay, so you have two plates coming together. You have bolt, and then you have washer sometimes, and then you have nut. And then when you tighten them together, you basically clamp the two together. Okay? So the purpose of bolt and nut is basically to clamp two things together. But when you clamp them together, you do not want to rely, okay? So you need to torque them such that it creates a pre-tension. So you're not relying on the friction. You don't want to rely on the friction. You actually rely on this clamping together. Okay? So when you tighten the bolt and the nut together, you're basically clamping. Now, if you thread the other side of the material, so let's say you are clamping two, this is part A, this is part B, and you want to bolt them together. What you do is you drill a hole, right, for the bolt. So you drill a hole, And then what do you do here? If the body of material is big, then you cannot have a nut on the other side, right? So let's say this is a thick one. So what you do is basically you drill and tap. So you might have a hole like this. It's a hole with a thread inside. And this is a clearance hole. So when you have a bolt going into the hole, okay, this is a clearance hole, and this is a tapped or threaded hole. So this hole is a clearance hole, meaning it doesn't bite into it. Even though you might have threads here, this is how threads are drawn, not like this, okay, I'm just giving you some visual here with the red color, but threads are symbolized like this. You guys took technical drawing, right?
Yes.
You also draw these things? Did you do this in SolidWorks?
No.
By the way, in technical drawing, what software do you use? Inventor, okay. But do you model threads and thread sizes and all that?
Yes.
You do?
Yes.
Yeah. So you have learned some thread sizes in technical drawing, right?
Yes. We didn't draw it.
You didn't draw the thread, but
Software.
specifications of threads. Okay. Now, when you when you create holes, especially for bolts, if you use the wizard, whether in SolidWorks or Inventor, I'm sure both of them has this wizard, where you can just select standard holes. So there are standard holes for clearance holes or for threaded holes. Okay? So here, this is a threaded hole because the bolt simply thread into it. Okay? It threads into part B. So as a result, part A is clamped to part B. The other situation is when you have a nut on the other side. Okay, so in that case, you have part A and part B might be thin. Okay, so this is A, this is B. So you're assembling two plates together, and so you have a bolt going through both. Okay, and on the other side you'll have a nut. So the nut have a female thread, but the okay, so the thread does not bite into part B. In this case, it bites into the nut and the two tightens together. You might have a washer here. Okay? So these are the two ways of assembling things. You guys, without the proper tools, will lean toward disassembly simply because you just drill a clearance hole for both, right? So here, you have clearance hole and clearance hole here. Here you have clearance hole on part A and threaded hole on part B. This is more difficult to manufacture if you are using your own tools, but hey, in the factory we have the proper tools. So they do this a lot, okay? Because it's just practical. Otherwise, with this, the assembly, you have to hold both. And you don't always have access to the back. Another way people try to assemble is, let's say you have two thin plates, okay? A and B are pretty thin, sometimes they're gonna weld a nut here. Okay, but the nut is actually welded to part B. So therefore, because part B is thin, you cannot do this. This is thick. So as a result, you just bolt a nut on the back. So when you put the bolt, goes through. Okay? So the bolt goes through and bites into the nut, not on part B, because part B is thin. But the nut here is welded to part B. So it's kind of, you can treat it as one thing. Okay, so these are just the different arrangement of bolted joints. And so if we go back to this, these do not have a counterpart, right? Because it's sharp threads. These are meant to be self-drilling. So they bite into the material and they create the thread. While here, to create the threaded hole, you need what is called a tab. You need a tab to create a female thread, and you need a die to create a male thread. I'll show you pictures of it later. Okay? So to create such a female thread, you're going to drill first, and then you're going to have something that looks like a bolt, but it actually is a cutter. You actually cut. Who here have seen a tab? Okay, so you actually cut and create the thread. But these things, they are self-drilling, so it is its own tab. Think about it. So again, just different heads also, right? This is a socket head, kunci L. They usually call it in Indonesia because the Allen key is L-shaped. It's called an Allen key. In the US, they often call it Allen key. Here, they call it a hex key or kunci L, like an L key. But that's not necessarily L, right? It's, I mean, many of these comes like that, right? But you can also have a straight, and then you have a T handle. So, right. Yeah, just different head. You can have slotted. You can have a Phillips. Same thing here. You can have a hex combination with a slotted. You got the thread cutting machine screws. You got the sheet metal screws. Sheet metal are very thin. That's why you just do a self thread. There are sheet metal screws with self-drilling. So at the end here, you have a very sharp pointed, not very sharp, I mean sharp enough to drill a sheet metal because they are soft. But you put this on your drill, and then you just rotate it and it will cut itself. It'll drill a hole and tap. Okay? Because the end here is like a drill bit, the end tip, the tip of a drill bit. So think of it like that. So it can create its own hole. Very practical. They use this a lot in canopy. If your house have a carport with a canopy, the canopy is built using steel hollow. So the big boxes are actually hollow. So think of it like a sheet metal basically because it's very thin. And then you put the canopy material. And the way they drill it, they use this because it's just practical. They just whoop, and it's in, right? It bites, it's secure. No need to drill and tap and tighten. So one shot for 3 processes. With this, you have to drill and tap and then put the bolts in. These are special types. They are used to hang things or to lift things. Eye legs, eye bolts. The difference is the thread type. This is a J bolt for hanging. A U bolt is often used to attach two pipes together. So you can come here and have a plate and you tighten round things. Shoulder bolts is a special type of bolt because this surface is actually very precise. Many bolts, the diameter of this is not that precise. The shoulder bolt surface here is meant to be a bearing surface. So you can put wheels on it or plain bearings. So you can do this for wheels. So if you have like say a set of wheels, okay, and then you want to tighten the axle, you use a shoulder bolt because with a shoulder bolt, notice that the shoulder has to be longer than the wheel, so that when you tighten it, you're not pressing the wheel against the chassis. So here's the like whatever, right? Whatever chassis you have. This is the wheel. This is the rotating wheel, right? So it needs to ride on this. But if you have the length of the shoulder longer than the width of the wheel, what do you have? You have this tightening against the frame, right? So it tightens itself here. But the wheel is actually free or kind of float. Think about it as it's kind of floating. So this is called the shoulder. So it can ride on that shoulder. If you have bearings here or bushings or even bearings, okay, no problem. So this is the special type of the bolts. Very useful because then you can put any rotating elements there. Now this is the opposite of those bolts, the nuts. Obviously the female is the counterpart of it, and then you have washer. What is the purpose of washer? They spread the load because see, when you tighten it, you can eat into the material a lot, right? Here, when you tighten the nut with part B, first of all, the nut will rub against it. Second, the nut is usually smaller, and sometimes you want to spread it over a bigger area, so you don't create damage here on part B. So the washer kind of spread the load of the nut over a bigger area. And it also have features sometimes to prevent loosening. We'll look at that. Okay, these are wood screws and sheet metal screws. They are self-tapping, self-threading. I want to show you the different kind of washers. Where are those? Okay, so while we are at it, here's the regular washers, flat washers. Fender washers is just oversized, spread it over a bigger area. Sometimes when you're assembling something soft, like a rubber or plastic sheet, you want to just spread it because otherwise you're gonna damage the material with the nut, right? This is just kind of a finished look. If you have screws that are sticking out, you put this washer, it's kind of gives you a nice contour. A split lock is one of the most common for preventing vibration to loosen up your screws. So you have the split here. If you look at it from the side, So it's like that. Okay? So the split kind of prevents the nut or the head of the bolt from backing out by itself due to vibration. Okay, so we have the external tooth or internal tooth, similar reasons you want to prevent it from backing out. Square, sometimes it's for a plate that you have a square recess already for that. Just different. You got sealing screw washers also, like the canopy that I mentioned. Usually they put a seal washer, so when they tighten it, water cannot get in and into. Okay. So sealing washers made out of rubber. Here are the different nut types. You got the usual, the most common one. You got the heavy version, usually thicker and bigger with the same thread size. You got the one with the nylon insert lock. The purpose is, I don't know whether you felt this, but it's there is some resistance as you tighten it because the nylon, there is a plastic nylon in it to actually give you intentionally some resistance to prevent it from backing out also. Jam nuts are arranged in ways, sometimes when you tighten two things together, like this is part A and part B, you don't want part A and part B to be clamped, but you need it assembled. Okay? An example of this is the sliding door. Sliding door. Right. It's hard to explain without some animation. Not this time. Well, I can use the same logic. Okay, so let's. Any of you have a sliding door in your house?
Yes.
Yeah. Over time, sometimes the door kind of drops and it starts rubbing on the floor, and you have to adjust the height. And the way you do that is you have these wheels on the top. So you have the carrier, okay? So the wheels rolls on the rail, and then it hangs on this thread. And this bracket is where your entire door hangs, okay? So I'm zooming in on the roller here. This entire thing is your door. Now, how do you adjust the height of this door? How do I raise it higher? Well, there are two things here. You got the threaded, you got the nut here, the jam nut. This is called the jam nut. And then the thread itself can be adjusted.